Welcome to MATLAB Tutorials, brought to you by Engineerize.com, where we engineer your rise.
This week we will start off with loops. A loop is another method to alter the flow of a program to execute a group of commands repeatedly. Each execution is called a pass, and the value of at least one variable changes in each pass. In MATLAB there are two kinds of loops: for loops when number of passes are specified, and while loops when looping continues till a specified condition is satisfied. The general structure of for loops is: for the index variable equals start colon increment colon the ending, then the group of commands that are to be executed, then end to mark the end of loop. How this works is: the index is assigned the starting value and the statements are executed. When it reaches end, a new pass begins with the index being assigned the next value. The statements are executed again with respect to the new value of index. After this pass, new pass begins with another updated value of index. This continues till index matches the value of end or the last possible value not exceeding end when the final pass is executed. After this, the loop finishes. Let's write a program on MATLAB to see how this works. For k equals 1 colon 3 colon 10, so the loop will run for 4 times with the values of k as 1, 4, 7 and 10 in each pass. Next, the statement that is to be executed each time. Say x equals k raised to the power 3. Then end to mark the end of the loop. Let's save and run the file. In the command window, we see the value of x has changed 4 times. Let's move on to while loops. The general structure of while loops is: while a condition, then the group of commands to be executed repeatedly, finally end. How this works is: at the beginning the condition is checked. If it is true, the group of statements is executed, following which the condition is checked again. Every time the condition is true, the statements are executed. The loop concludes once the condition is found false. So let's write a program with while loop. Often it's a good idea to start with clear_all and CLC while using loops. Let's define two variables. First equals 1 and choice equals y. While choice is equal to either small y or capital Y. If this is first pass, input a number for a and change first to 0. Else take input a number for a new element of a. End for the if statement. Input choice, asking the user if there is another element to enter. End for the loop. Now display the final array. Now let's run the script file. Enter a number to be stored, say 20. Do you want to store more numbers? Y for yes. Again, enter another number to be stored, say 50. Do you want to store more numbers? Again, yes. This time 30. Press N for no. So it displays the numbers we have stored. Let's turn on echo to understand what happened. Since we had initialized choice with y, the while condition is true and it entered the loop. Again, since first is 1, this is also true. And this group of commands were executed.
20 was assigned to A. After that, this input command is executed, and since we entered Y, the while condition was true, the loop ran another pass. But this time, first is 0, that is false, so the else portion was executed. And the input 50 was stored as the next element of A. In the next pass, 30 was stored as the third element. We input choice as N, so the while condition failed and the statements after the loop were executed. That is, the stored values were displayed. Now that we have covered loops, there are two commands that you should know. First one is the break statement. When MATLAB encounters the break statement, the control jumps after the end of the loop. It is like an emergency exit. Next is the continue statement. When this is encountered within a loop, the control skips the remaining statements and starts a new pass. These are generally used within a conditional statement. Now we'll move on to user-defined functions. A user-defined function is created by the user, stored in a function file, and can be used like a built-in function. Function files are like script files, but with input and output, and are convenient when it needs to be evaluated many times for different values of input. Functions can be created and edited in the editor window. If you create a new function, it opens with several pre-typed outlines. The first line must be the function definition line, and the first word must be the keyword function. Then the output argument, say SI, equals function name, say sinterest, then within brackets the input arguments, say p, r, t. Now before we go on to type commands, we should put some comments as help text. The first comment is the H1 line. Calculates simple interest from principal, rate and time. Next, inputs P equals principal, R equals rate, T equals time. Output SI equals simple interest. Next, the function body. This is where the actual code is written. SI equals P asterisk R asterisk T divided by 100. Now let's save the file. The file name should be the same as the function name, so we'll save it as sinterest. Like script files, this also has the extension .m. A user-defined function is same as a built-in function and can be accessed from the command window, script file or another function. Let's see how this works. We can also pass the inputs indirectly as variables. Notice that in the workspace, the variables used within the function are not present. A function works separately with local variables, unlike script files. User-defined functions are used for complicated subprograms, but for one-line functions, this is a lot of work. There are methods to define functions without creating and saving an M file. We'll discuss more about them next week. Thank you.